Hi, this is Discrete, section 4.1, modeling projects with graphs. And so what we want to try to do is use the power of mathematics to help us schedule. And to set up scheduling, we have to draw models to help us do that. So let's go through a couple things here and see what we want to do with this unit. So the first thing is that you will be able to model a project with graph of vertices and edges, and then also find the least amount of time to complete a task. More so, the second objective there will be from section 4.2. So let's start off with an example, and this will lead you through some of the paradigms that happens with this graph. So if we look at this one, cleaning the garage. Say, for instance, me and my brother have to clean the garage. After we are done, you can go to the game. So I put things away and my brother sweeps. If it takes me 20 minutes to put things away and my brother 1 hour, we can do these things both at the same time. How long is it before we can go to the game? Well, I think the answer is obvious, hopefully it is that the longer of these two is the shortest amount of time before we can get to the game. So when we do some scheduling later on, it's actually the longest path, which will be the shortest amount of time before you can move on to the next task to complete. And that's what's going to be happening. So this is one example that will lead to our conversations later on. So first of all, some examples. If we want to make a graph and find the shortest completion time, we have some tasks laid out here, A, B, C, D, E, F, G, and we have some certain times that it takes each one of these tasks to do. And then we also have what we call prerequisites. So for instance, to complete or to start task B, I will have to have started and finished task A. Also for task C, I would have to complete A to move on. Now, some of these are independent of each other. So if you notice, B and C are independent of each other, so they can run concurrently. So this will help us minimize time and to complete tasks sooner. So businesses use this a lot to say, okay, I need workers from this task over to this task so we can get this thing done faster because this is our bottleneck. This is what's slowing us down. And so this is really useful for businesses in figuring out what to do with it. So on your note sheet, this is the backside. We're actually going to look at this first. We have a starting point, and then we have schedule of events, A, C, B, all these different ones, and we coordinate. And then we finally finish over here. How is this scheduled? Well, what happens is that, for instance, if I go to task D, that means that I have to complete task A, B, and C first in order to get to D. Also, if you look at D, we put the time that it takes D after the amount. And so I start task D and then I work on it, and I finish, and then I can go to F. So this time is the time for D. And so that's how it sets up. So for instance, task A doesn't take 0 time, it takes 2 units of time, whatever that is. So this is the type of graph that we're going to be making for the data that I just gave you. So here it is again, the start time and all these other things on here. Okay, so with this, we're going to start. I want to go down here. So if we start here, we say that task A usually will start at the top. A is the only one that does not have any prerequisites. And so that's how we're going to start. And so it's going to take us 0 to start. But once we start A, then A will be completed in a time of 4. But let's try to get the graph down first and then put the time units in after. So then the next item would be to put what comes after A. So I look at the prerequisites. A leads to B, which leads to C. And since there aren't any over recurrences there, I'm going to go like this. And so that would be my B, and that would be my C. And then from there, what is my prerequisite for D? Well, it looks like it's coming out of B. So before I can complete D, I got to do B. That's what it tells me. If I do E, I got to do B and C. Uh-oh, what does that mean? So I'm going to draw it there. Well, leading from C to E What else do I have to do? I have to put B to E. So that's how we're going to draw it. And then if I look at my next prerequisites for F, it would be D. So I can put out F here. And then anything else, we got a G. So further out we have a G. And G, the prerequisites are E and F. So I got this one coming and this one coming. And then I can finish. Can't fit it in there, but that's finish. Okay, so now we can put the times on these. And so the completion time is the time that goes after the amount. So for instance, A completes in 4 time units. So after A, I'm going to put a 4. And notice down here I have A2, and so I'm going to put a 4 there. So completion time for A here, completion time for A here. And then for B, it's 5 units. And then so I'd have to put 5 on both of those. For C, it's 2. And for D, I'm looking at 6, F, 6, E is 5, is there, and then G is 8. So those are the times that I have. So this is how we're going to make a graph. Later on, we're going to figure out what the longest path is, which is our shortest completion time, actually. Weird, huh? Okay, but that's how it works. It will make sense later on. Okay, so 1, you got to take a chart of information and turn it into a graph. And now 2, what you have to do is take the graph and turn it into a chart of information. So this is on the flip side. So our task here, what we have is A, B, C, D, E, F, and I don't see G. Okay, so that's what we have. So how long does it take to complete A? You can put these things in. And then C looks like it's, so here it is all filled in. So those are the completion times for each one. Now what we want to look at is what are the prerequisites for each? And so what do we have leading up to each one of those that we need? So for A, we have no prerequisites. It looks like for C, we have no prerequisites as well. And then for B, yes, we have a prerequisite. What comes first? Well, A does. How about maybe you answer some of these? What's the prerequisite for D? You can figure that out. Prerequisite for E and prerequisite for F. Well, it's both D and E because I have both of these lines coming from there. And then we can go ahead and finish. The prerequisites are everything for that. Well, we don't write that. But that's what we got. And so that's how you would set up the task table for that graph that we were given. Okay? So hopefully you can do both of those, and that would be what we have for section 4.1. And then that's the homework as well. Thank you very much. Read through that section if you need a little bit more information. It's pretty clear. But that's the start of us helping us schedule things and do things well. Thanks. Bye.